Hi everyone, welcome to my YouTube channel Vocational Door. So, happy new year to all of you. And today we will discuss one famous lead code problem, which is merge sorted array. So, in this problem, you will be given two integer arrays, nums1 and nums2, and both of these arrays are in non-decreasing order, means in increasing order, and they are sorted. And you will be given two integer m and n. These numbers will represent the elements of nums1 and nums2. What we need to do, we need to merge nums1 and nums2 into one single array, and that should be sorted in non-decreasing order. And also, we need not to create a new array and return it. Instead of that, we need to modify this nums1. To accommodate this, nums1 is having the length of m plus n, where m is the elements which will denote the elements that should be merged. So suppose for this first example, we are having this nums1 array and m value is 3. So it means three elements 1, 2, 3. These will be merged, and n denotes the number of elements in nums2, and also this same number of elements in nums1 will be denoted as 0. So those should be ignored. So let me reiterate this via example. So suppose in one example you are having nums1 where we have 6 elements, value of m is 3. In nums2 you have 3 elements, the value of n is equal to 3. So all these elements 3, those should be merged in num1, and the final output should be in a sorted order, which should be in non-decreasing order. And there is n is equal to 3, so 3 elements are 0 here. Those should be ignored. Instead of these three elements will be merged here, and the final array should be in sorted non-decreasing order. So this is our target. So you can see, if we will merge this in array, so suppose this will be 1 2 3, then 2 5 6, then we want to sort it in non-decreasing, so final result will look like 1 2 2 3 5 6. So that's how we need to calculate our final output. Same we can see this another example where nums1 is equal to 1 and m is equal to 1, and nums2 is empty, so n is equal to 0. So it will remain same, so 1 will be the final answer. So like this, we need to find the final answer, and we will discuss like how we will solve it and what will be our approach. So we will see. So to solve this problem, we have taken two arrays, nums1 and nums2, and the values of m and n, which are 3 and 3. So to solve this, we can start comparing from the last element of nums2, which is 6, with the last valid elements of nums1, which is 3. So in this, whatever the bigger is, which is 6, we can fill in the last index of nums1. So for this, we have taken three pointers I, j, and k. I is equal to m minus 1, which will come here at 3 for the nums1. J is n minus 1, which is for nums2, which will come at the last index of the nums2. And k is m plus n minus 1, which will come at the last index of the nums1. So this I have taken to fill the elements in the nums1. So first what we will do, we will compare ith element with jth element, and we will see which is the bigger one, and whatever the bigger one will be, we will fill at the k. So suppose here 3 and 6, 6 is bigger, so we will fill here 6. So array will look like 1 2 3 0 0 6. And since this nums2 was bigger, so we will do j minus minus and k minus minus. So after this, what will happen, this j will come here and I will remain here, and k will come here because we have filled this one with 6. Then in the next step, what we will do, we will compare this 5 with 3. So in this, like 5 is bigger one, so array will look like 1 2 3 0, then this 5 and 6. Since again the nums2 was bigger, so we will do j minus minus and k minus minus. So after this, j will come here and k will come here because we have filled this one, and I will remain here. So array will look like 1 2 3 0 5 6. Now again we will compare this I with j. So this 3 with 2. Now 3 is bigger one. So from the nums1 it is bigger. So we will do I minus minus and then k minus minus. So the array will look like 1 2 3, and here we will fill 3, which was bigger one in these two, and then 5 6, which we filled earlier. So after this, the pointer movement will be like I will come here and k will come here, because till this we have filled 3, 5, 6. Now we will compare this I and j. So both are equal. We can keep any of these. So here, like I have written, 2 will be compared with 2. So either will work. So what we will do? We will do j minus minus. So after this j minus minus, what we can do? It will look like 1, 2, 2, 3, 5, 6, and the pointer will be moved after this. So j will be like minus 1. So as after this, like j will go beyond 0, which will be minus 1. So we will exit our mechanism. So for that, like we will apply precondition of while j is greater or equal than 0. So like this, we can solve our problem. Now we will see in pseudocode like how this will work before jumping to the actual lead code. So in pseudocode, we can understand like whatever I have explained in the theory. So we will take 3 pointers I, j, and k. So I will be m minus 1, which is the last valid element in the nums1. So which is last valid means last non-zero element in the nums1. And for the j, we have n minus 1, which is last element of nums2, and k is m plus n minus 1, which will become eventually the last position in the nums1, because we need to modify the nums1. We need not to use any extra space, so we will not be creating a new array for this. And after this, we will start one while loop, and we will check till the point j is greater or equal than 0. And after this, we will start comparing from this I and j pointer, whatever will be greater. We will put this at the k position, and then we will decrement our pointers accordingly. And after all these, like we will be all set. Like our nums1 will be containing the all sorted elements in the non-decreasing order. So what was the actual requirement? So now we will see how we will code in Java on the lead code. So here we will start our coding, where we will take 3 pointers. First will be I, which will be m minus 1, last valid element in nums1. Then j, which will be n minus 1, last element of nums2. Then int k, which will be m plus n minus 1. It will be the last position of in the nums1, where we will start filling. Now we will start loop, and first we will check till j is greater or equal than 0. This I explained in the theoretical part. And inside that, we will start putting our condition. First we will check if I is greater or equal than 0, and with that nums1 at I, because this was the pointer for nums1, is greater than nums2 at j, because that was pointer for nums2. If this is true, then what we will do, nums1 at k position, we will fill, we will assign this nums1 of I. And if this is not true, then we will go into the else part. Here we will assign nums1 of k to the nums2 of z. So as I said in theory, if this is true, so we will decrement ith pointer. If this is true, we will decrement jth pointer. And after these, we need to decrement k pointer also, because we are filling from the last element, and it will go move towards the left side in the array. So in this way, our code is completed and our nums1 is modified as per our requirement. So we will execute it. So we can see all these cases are getting passed. Now I will submit to see if the edge cases are getting passed or not. So we can see all the cases are getting passed, and this is very optimal solution, because the time complexity will become O of m plus n, because max to max we will iterate over m and n elements, and its space complexity will become O of 1, because we are not using any extra space, we are modifying nums1 itself. So thank you for watching my video. If you guys are having any suggestions for me, please comment, and keep learning. Happy learning.